In this video, we are going to look at the exercises that you have to work on. And so we already talked about Boole expressions and operators in the previous video. I made that a whole video. So the exercises we're going to look at, this is a preview of what we're going to see in this video. So we're going to look at the exercises. We're going to have these exercises right here. So one exercise will allow us to work with multiple returns, and we'll kind of have a chance to work with that. And func expressions, that'll be another exercise, and then a variadic func exercise, and then an exercise that asks us to work with Boole, right, and to evaluate Booles and operators, Boole and operator. And then we'll have a variadic exercise again, and then also there's something called Project Euler, which we're going to learn about. And so we will learn about Project Euler, and you will have one exercise that uses Project Euler. And so here are all of your exercises, just in case for some reason you're not at this document and you just want to look at it off this screen. And then we have a solution to all of the exercises. And the solution for all the exercises actually is moved up one, so I need to change it. And you can find the solutions to all the exercises by coming to Golang Training at my repo and, at my GitHub account, going to the Golang Training repo and then clicking 16 exercise solutions. So I'm going to copy that and then put that in right there as the place to go for the exercise solutions. So there are the exercises, and I think you could read through these and they're pretty self-explanatory, and if you have any confusion about them, you can look at the solutions and try to work these without looking at the solutions, because that struggling is what actually helps you learn. And but at the same time, don't let yourself struggle too much. Like, don't get to the point where you give up and just stop programming, because one of the most important ways that you learn about programming is to struggle a little bit, not too much, and then go look at how somebody else did it and see the solution, because you're going to like try, get these, and then you look at somebody else did it and you'll be like, oh man, I should have, why didn't I think of that? And so looking at the answer is actually very helpful. But it's most helpful if at first you don't look at the answer for just a little bit and expect to learn by not being able to solve it and then having to go look at the answer. Like, expect that to happen. But allow yourself to struggle just a little bit. All right, so that's those are the problems, and that's where you can find the solutions. And here's Project Euler. So Project Euler is a website where you can go and you could read sort of the premise behind it and then who is it aimed at. And you could come in here and you could find all kinds of problems in here, computer problems. So if I go to archives, right, here are multiples of 3 and 5, right? Here's a problem. Or even Fibonacci numbers, or largest prime factor. So all these are, different problems that you could come in here and you could say, okay, let me see large sum, right? Like large sum. You could come in here and work out the first 10 digits of the sum of the following 150 digit numbers. So each of these, right, is one number, and there's 100 of them, and they want us to work out the first 10 digits of the sum of the following. So once we add all of this up, what are the first 10 digits of the sum? So once we add them, what are the first 10 digits? Whoa, that's a lot of stuff, right? So good to think about and see if you could solve it. So that's Project Euler. And we are going to do a problem with that. All right, so let's look at the solutions, and I'll just kind of talk through them. And if you haven't done the problems yet, go do the problems. And then if you're stuck, you can come back and either look at the solutions on GitHub or come back here right to this point in this video, and I'll talk you through the problems. So the first problem is to write a function which takes an integer. The function will have two returns. The first return should be the argument divided by 2, so whatever argument got passed in, you're going to divide it by 2 and then return that. And the second return should be a bool that lets us know whether or not the argument was even, right? So the number that got passed in, was it even or odd? So for example, if I call my function and my function is called half and I pass in the argument 1, that is going to return 0 because 1 halved is 0.5, but since these are ints, it just goes to 0, and it's going to return false, right? And this half 2 will return 2 divided by 2 is 1, and that's even, so it will return true. So let's see that in action. And I provided two solutions here for you. And the first one does it with an int, just so you could see how that works. And then the second one does it with a float 64, which will give us some decimal values. So the first one here, bring up the terminal. And let's go there. So change into Go code, source, GitHub, goes, I'm sitting at an angle to my keyboard. Goes to 11, and this is Golang training, and 16, and 01, and then 01. And go run main. And so 2 false is what that returned. And so I have my half function. And so here's my half function, and it takes an int and it assigns it to the variable n. And so whatever gets passed in, I take that and I divide by 2, and then comma, I take that again and I get the remainder of that. If that's equal to 0, this expression will evaluate to a bool, type bool, and that will be either true or false, right? And so that means that there's no like remainder when it's divided by 2, which means it's even. And I'm returning that. And here is how I do my multiple returns, so the int and the bool. And so when I call that, I have to assign those to 2 variables. So here's the value that comes back, right, which will be the argument that's passed in divided by 2. And I'll assign that right there. And then even will tell me if it's true, that is even, if not, false, and then I print those out. So when I pass in 5, I get 2. Because 5 divided by 2 is 2.5, which becomes 2, since it's an int, and then even, right, is false because 5 is not even. If I made this 8 and run it again, it should be pretty obvious, 4 and true. Pretty cool. So I'm going to leave that as 5. And the next one is the exact same thing, but I changed the return to float 64. And so, that's what's being returned right here. And then the float 64, I have to take my int and convert that to float 64, and then I can divide by 2. So let's see what that gives us when we run it when we divide by 5 or pass 5 in. And I need to go into, what is that, 02. Go run main. And I've got 2.5 and false. That's cool. All right, so that's the first problem. And then the next problem is modify the previous program to use a func expression. What? So that's a really good question. How would you modify this to make it a func expression? And, yeah. Another question that kind of comes to mind is why would you want to do that? So maybe you want to limit your scope a little bit. And right now half has the scope of package. Maybe I don't want that to have the scope of package. Maybe I have a function and I want to put another function inside of it just to contain the scope. And so to do that, it basically looks like this. And so I've taken half, which used to look like this. Right? So basically I took this and I brought it down in here. And I can't have that in there like that. So I said, all right, no problem. Let's just do half colon equals and take this out. And there we go, right? And so that's pretty much what I did. Half colon equal func. And here we have half colon equal func. And I don't know why, but when you do it like that, where I just brought this function down, right, from up here, and then I bring it down, and then I paste it in, and I say, well, we can't do it this way. We got to assign it to a variable half, which is a func expression, and then I'll take that part out. It's like, oh, that totally makes sense. But, when you just look at it like it's already there, it's like, how did you go from this to this, right? That's a little bit of a harder jump, it seems, sometimes for people. So there we go. That's the func expression. I'm just making sure this one's all cool before I commit it. Otherwise, I'm going to put it up to GitHub, and people will be like, it does not run. Let's just make sure it's still running. Go run main. La la la. Awesome. All right, and we can make sure this one runs too. So this is in func expression, so I need to go up, 02, and then go run main. Nice. Runs. We'll make that 5. true and false. It's not even. So that's pretty cool. The next problem is the variadic greatest. And here we have write a function with one variadic parameter that finds the greatest number in a list of numbers. So function with one variadic parameter. So variadic parameter, right? You should already be thinking I need the dots in front of the parameter. If I was passing something in and it had, like a bunch of, if it was a slice and I wanted to get all the variables in there, all the values in there, I do it like that after the argument that I'm passing in. And I know that it takes a little bit of time just sort of get that, but you will eventually. And that's why I just say it again so you're familiar with it once more. So the way we would do that, write a function with one variadic parameter that finds the greatest number in a list of numbers. This is how we would do that. We would go, function main. I always like to start there when I'm trying to understand a program. Calls max, and it passes in just a bunch of numbers. So max needs to receive a bunch of ints. So that's my variadic parameter, right? Makes it a variadic function. And I assign that to numbers. And we've already saw, and we could see that again if we wanted to. We could do format.printf. And then we could do %t. And we could say what type is numbers. And we'll see that that is a slice. And so we haven't learned about slices yet officially, but you're aware that, okay, it's a list with a bunch of numbers in it. And so then I could range over it, right? Like if it's some sort of a collection with a bunch of stuff in it, I could range over it and loop over it. And so we already saw the range loop. And when we use the range loop, it gives us back, 2 returns. And it's going to be like the index and the value or the key and the value if it's a map. And so these can be called anything you want, but it's pretty much the same thing. Like an index and a slice is pretty comparable to a key and a map. It's the thing which allows us to access that one item, and then what is the item, right? So that's what we're getting right here. So this is kind of like how we get to the item or where the item is at, the key, or the location, the item, we could see that, right? And then here's the value. So here we create another variable, which is largest int, and since it's var, largest int, sets it to its 0 value, which would be what? What is the 0 value of an int? So that's a question for you to answer. Pause the video. You got it? The 0 value of an int is 0. And now we loop over these. And so if the current value is greater than what is the largest value, so the first time through it's 0, so if this number is bigger than 0, largest is we're going to assign that number, which is now bigger than largest, to largest. So largest becomes that larger number. And then we just loop through every time, and it's pretty cool. I like just the simplicity of that. And if the number is bigger than what's currently our largest number, well, then that's what largest becomes. It becomes the bigger number. And then we just return largest, which is an int. And so when we run this, right here, we're assigning, the largest number to greatest, just a different name, so there's no confusion there. And then here, we print it out. So when we run that, change, and go run. We've got slice of int and 543. That's kind of confusing. Let me put in a new line right there. Slice of int and 543. So that shows us that this type that got passed in is a slice of int. And then it also says the largest number is 543. And sure enough, if you look through that list, that is the largest number. So I'm going to take this line out just so the code is clean. And but I thought that was valuable for you to see that it's a slice, right? That's what numbers is when we pass in all that stuff. It becomes a slice. Kind of cool. So the next thing is a Boole expression problem. And the way this problem is articulated is what is the value of this expression? I'm going to change that to this. And true and false, false and true, and not false and false. So what did we learn? If you have cake, if I want cake and ice cream and you don't have both, I'm not happy. So this evaluates to false. So we'll just remember that like by maybe, I don't know, for you and I right here, right now, we'll make that's not a good color. We'll make that red. That's what it evaluates to. And then false and true, right, again, is going to evaluate to false. right? Because I want cake and ice cream. I'm sorry, I only have cake. I'm not happy, right? You had cake, that's true, but you didn't have ice cream, false. I'm not happy, I want cake and ice cream. And then down here we have false and false. Well, that evaluates to false, right? Because, I want cake and ice cream. Sorry, I don't have either. What? And then we have the ors. And so it's like, do you have cake or ice cream? Yes, I have cake. Great, I'm totally happy. So do you have false or false? Because now we're looking at right in between because we have parens. So we run those first inside the parens. And then now we could, do these. So false or false, I'm not happy. But that would be false, right? That's what that evaluates to. So then I have false. All of this evaluates to false. And over here I have not false, which becomes true. So if I have false or true, I'm happy, right? And so this is going to evaluate as true. So that's how you would just sort of like think through that logic. And let's watch the program run and see the result. Yeah. All right, so here is all I did to evaluate that programmatically. I'm just going to print the result of that expression. Here's a print statement, and it's a whole line. And here's the expression. So the statement contains the expression. And so yeah, just using those words again. So run it. Let's run it. Why do I have two terminals open? Go run main. Which one should I go with? I'll go with that one. That's the last one we used. All right, so O3, change directories. O4, and go run main. And true. Ah, how sweet it is. There's always like, what did I miss in programming? So when I'm recording these videos, I'm kind of like, sometimes I'm like, is that actually the way it's going to run? Did I miss something? It's kind of funny. And so the last problem, actually two more problems, write a function foo, which can be called in all of these ways. So if we have func main and somewhere else in our program we have foo and we're calling foo, and let me just ignore all on that and ignore all on that so we're not seeing those things. Right, if I have func main and we're calling foo in all of these different ways, so I could call that, and I have a slice, and then here I'm passing in each of the values of the slice, so there I am passing in an argument with multiple values. Oh, so that's the thing I was talking about before, and when we did it with parameters, we had the dots in front. And I could also call foo this way. So foo is going to be a variadic function, and a variadic function can take 0 or more arguments. And it needs to be a variadic func which takes an unlimited number of ints, right? From 0 to an unlimited number of ints. So I'm going to have int, int, sorry, 3 dots, int. That will be my, so when my foo declaration is going to be, func. And then if I had a receiver, it'd go here, but I don't. So now next is going to come the identifier, and then the parameters, and I'm going to, not food, and I'm going to have n, and it's going to be, since it's a parameter, the dots are in front, and it's going to be, variadic number of ints. And then here I would have my return, and my return is going to be whatever I want foo to do. So it's probably going to return an int or something. It's going to add them all up, and then here would be my logic where it runs. So let's go see how that looks and run it. And so here is params and args. And sure enough, right? I guess all I'm doing is printing the numbers. And so that's going to print what? Another really good question for you. What will this print? And when I run it. So when I run it here, what will it print? When I run it here, what will it print, right? And so it's going to print a slice. That's what it's going to print. And it'll be a slice with whatever numbers I've passed into it. And so that's just because that's what, a variadic func does when you pass in a bunch of stuff. It turns it into a list. All right, so let's watch it run. CD 05, go run main. And there are my different lists with the brackets. Those are my lists. So pretty dang cool. Now for this last exercise, I want you to find a problem at projecteuler.net, then create the solution. And I want you to add a comment beneath your solution that includes a description of the problem. And I want you to upload your solution to GitHub. And I want you to tweet me a link to your solution. How cool is that, right? And so just go to Project Euler and dig through here until you find a problem that looks interesting to you. And so maybe I do multiples of 3 and 5. And then once I've worked out my solution, I'm going to take the text of the problem and go to my code. And so if this was the one where I'd worked out the solution, I would put in here, just what the problem asked me to do. And sometimes in WebStorm, with comments, I don't have automatic wrapping on, and so I have to hit return. I don't know. I just haven't taken the time to do that, and I kind of like it without that. But so put your code, the description of the problem there in a comment, and then push it all up to GitHub, and then go get the URL, for that, and then tweet me a link to your solution. And if your URL is too long for whatever reason, you could go to Google short URL or Bitly or one of those other sites, and you could take your URL and drop it in there if you've never seen this. And so here I have a really long URL and I dropped it in here. Let me just show you. I don't know, where can we go? I guess right here. That's kind of long. I don't want to send that to people. So these are the exercises, and I can put that in there and then just shorten the URL, and then bam, gives me this. And so now I could just copy that and put it there, and it gives me the short URL, which is just a reference to a longer URL. So those are your exercises and your problems, and I totally look forward to getting your tweet and seeing your solutions. I think that's going to be totally cool. And when you send me your solution, tell me where you are in the world. Hey, I am in wherever it is, because I love hearing that I made this video and whoa, people in Madagascar are learning Go. That's so cool, or wherever you happen to be. So tell me where you are in the world. That's kind of fun, and also show me your solution. I look forward to seeing it, and I wish you good luck. Programming is fun. That's it. It's fun to try to find the solution. So I look forward to seeing the solutions you came up with.